Okay, in 6.2, we are going to focus on multiplying and dividing radical expressions and also reviewing simplifying radicals. So to start, we want to talk about our perfect square list. And these were things that we used earlier in chapter 4 when we were talking about simplifying with square roots. So our perfect squares are 1, 4, because that's 2 squared, 9, because that's 3 squared, 16, 25, 36, 49, 64, 81, and 100. And sometimes I go further and do 121 and 144 as well. But these are the perfect squares that you should be very familiar with. It's a list that I often keep on the board and just leave it there. I put it at the top of my homework paper and leave it there as a reference list. So back in chapter 4, we talked about how do we simplify perfect squares by finding the largest perfect square factor that goes into what's under the radical. So for example, 24, the square root of 24, 24 is not a perfect square. So we look in that list and see what goes into it. So we break it down. The biggest perfect square, the only perfect square that goes into 24 is 4. So we break it down into 4 times 6. Take the square root of each one. Square root of 4 is 2, and then the square root of 6 is left because it is not perfect, nor does it have any factors that go into it. Same thing with 32. Now 4 goes into 32, but we actually want to go as big as possible. 16 will go into 32. So then we take the square root of 16. Square root of 16 is 4, and then we leave the square root of 2. And then finally 300. 300 breaks down into 100 times 3. Take the square root of the perfect one. I always write it first, which is 10, and then leave the square root of 3 as is. So those were some simplifying radicals that we did with our perfect square factors. So when it comes to multiplying radical expressions, if we have different radical expressions, we now realize there's more than just square roots. There's cube roots, there's fourth roots, there's fifth roots. The index number, which is on the tip of that root, is what tells us what type of root it is. If both roots, both radicals, are the same type of root, both square roots, both cube roots, we are allowed to multiply what's underneath them together and then see if I can simplify the result. If they are different roots, we can't do that. So when we look at these 6 and we're looking and comparing roots, what you're going to notice is this one in this group has 2 different radicals. You have a cube root and a square root, different radicals, so we're not going to be able to use that rule. And then the bottom row, the middle one, has a fourth root and a fifth root. So I want to focus on the ones that have the same radicals so I can simplify them. So the first one has a square root of 10 and then a square root of 5. When I multiply the square root of 10 times 5, I get 50. And then I'm going to break that down using that list that we just talked about. 50 breaks down into 25 times 2. Square root of 25 is 5, so we get 5 root 2. And we did questions like this in previous chapters. The next one, both are cube roots. We can multiply negative 4 times 2 together. We get negative 8. Cube root of negative 8 may be something you know off the top of your head. It's also something we can work on our calculator. It is a perfect cube. We get negative 2. On the bottom left, these are both fifth roots, so I'm going to multiply the negative 5 times the negative 2 and get 10. So I get the fifth root of 10, and I'm not going to be able to do anything with that. We're going to talk about common fifth roots that you might see in a second, but 10 is definitely not one of them. And then the last one, the 20 and the 10 can be multiplied because they are both being square rooted, so we get 200. We're going to break that down into 100 times 2, and then we're going to take the square root of 100, which is 10, and we get 10 root 2. So if we have the same type of radical and they are multiplied, we are allowed to multiply what's underneath and keep that radical. So as we start to work with higher radicals, so instead of square roots, we start to work with cube roots or fourth roots, there are a certain list of values you should know, kind of your basic reference list that you're going to use throughout the rest of this chapter. So we've already talked about our perfect squares, but I'll just kind of put them back up here in case you want to have that comprehensive list again. I do usually go to 12 squared, so I do usually go to 144. So that's how far I'm going to go on this one. 121 and then 144. There are not as many perfect cubes that you should be comfortable with, and I've talked about them a little bit already in previous videos. 1 cubed is obviously 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. After that, obviously, you can keep going 6 cubed, 7 cubed, but you won't see many bigger values than that as references. For the fourths, it's even a smaller list. So 1 to the fourth, 2 to the fourth is 16, 3 to the fourth is 81, and honestly, after that, you don't see a lot of 4 to the fourth or 5 to the fourth because the numbers get really big. And then for your perfect fifths, again, obviously 1 is a perfect fifth, 2 to the fifth is 32, and truly after that, we don't go much higher with our simplifying. We could do 3 to the fifth, it's 243, but you start to get really big numbers after that. So these are the common ones that you should know. So we're going to go through this and kind of ends I want to show you some basic ones, but we're not going to go too much further in this video because I want to just kind of look at numeric pieces here for a second. So if you're asked to put a radical in simplest form, the goal is to take out anything that is perfect inside. So if it's a square root, you're looking at the perfect squared list. If it's a cube root, you're looking at a perfect cube list. So you're always going back to this list and making sure you're looking at the right one depending on the root. Square root, you're going to look at your square list. Cube root, you're going to look at your cube list. Fourth root, you're going to look at your fourth list, and fifth root, you're going to look at that list, which is obviously very short. So 24, we actually already did this one, is 4 times 6 because 4 is a perfect square. So we get 2 root 6. But if you're doing the cube root, now we want to look at the perfect cubes list. And so we're not working with 4, we're actually working with 8. 24 is 8 times 3. So now when you take your root, you're taking the cube root of it. The cube root of 8 is 2, and then you have the cube root of 3. So you're going to be looking at numeric ones, but you're now not just looking for perfect cubes. Depending on the radical will tell you which perfect list you're looking at. So that gives you just kind of a basic introduction to 6.2.